Alright, hello, this is Mr. Crutch. I'm going to go over some of the homework problems here. 30A gives you two vectors and the idea is to add them. So I'm going to show you two different ways to do that. Well, first thing you can do is draw both vectors, and that first one would be 2 in the x direction and 3 in the y direction. So there's that vector. Go ahead and draw it, make sure you put an arrow on it. The next one is a 4, 0 vector, so that's 4 in the x direction, 1, 2, 3, 4, and nothing in the y direction. So there are my two vectors, and the idea is to add them. Well, adding them is a resultant, so where would that be? Well, what you do is you take one of them, either one, and just go ahead and draw it again. So I'm going to draw this vector again, 1, 2, 3, 4. And there's that vector again. And if I were to draw this vector again, it would still be up here because that would be 2, 3. And that resultant is the line in the middle. It's the resulting line if you put both vectors together. Alright, now what that looked like on our project earlier this week is we just drew them back to back. We draw this first vector, which would be over 2 up 3. There's the first vector. And the second vector is 4, 0, 1, 2, 3, 4, 0. There's the second vector, and we would just simply come in and draw the resulting vector that way. Either way, we still have the same vector, and the vector is just simply adding them. That would be 6, 3. 6, 3. Over 6, 1, 2, 3, 4, 5, 6, up 3, right there. And if you want to write it as linear combinations, it is on the I-axis and J-axis, 6i plus 3j. Alright, number 50 gives you an initial point here and a terminal point here, 1, 2, 3, 1, 2, 3, 4, 5, 6, up there, and it's asked, what is that vector? Well, the vector goes over 3 and then up 8. Over 3, up 8, the vector is 3, 8, 3i plus 8j, however you prefer. And we can get there by subtracting back. 3 minus 0 is 3, 6 minus negative 2 is 8, and also I ask you to find the magnitude, so that would be just Pythagorean theorem, right? 3 squared plus 8 squared, square rooted, 73, 8.5, sure, that looks like about 8.5, and inverse tangent of 8/3, and if I were to draw a unit circle there, that definitely looks like about 69.3 degrees, 69.4 degrees. So you can always measure this on the graph to make sure it's right. Alright, some other problems you're going to run into. Problem 65. You can use CalcView. There's a great video for this. The guy explains it the same way I'm going to do number 66. On 66, they give you the magnitude of a vector and the angle. Well, the angle is easy, right? The angle is this 45. So what is 2 root 3? Well, that's about 3.5. So whatever you want to call 3.5, I'm just going to label it. That's 45 degrees. Here, this is 2 root 3, or about 3.5. And now what are the components? Well, the components here are 3.5 times cosine of 45 degrees, and that comes out to be about 2.5, and 3.5 cosine, 3.5 sine of 3.5, didn't get that one right. We're going to put in here about 3.5 times sine of 45. There we go, that looks a lot better. And it should be equal, right? Because it's only 45 degrees, and this would make isosceles triangles. However, when you see something like this and you see something like this, the first thought in your mind should be unit circle. I can do this problem with the unit circle, right? This first value right here is the magnitude times the cosine. And what's the cosine of 45? That's root 2 over 2, which would be 2 root 6 over 2, which would just be root 6. And the square root of 6 is about 2.4. So There are going to be some questions on the quizzes and tests which ask for exact values, so just do it with the unit circle. You can definitely estimate and see where it comes from, but what you really want to make sure you do is use the unit circle so you have exact values. Alright, number 77 gets to this problem where we have a vector pulling this way at this amount of force and a vector pulling this way at this amount of force, and there's a 45-degree angle in between them. Well, what you want to see is this is, in our analogy in class, this is the plane and this is the wind. So what's going to happen if I have a plane going this way and a wind going this way? Well, I'm going to take this wind and redraw it over here, and the wind's going to push the plane, and the plane's going to go out here. And what you should notice is that is the same picture that we see here. Two different vectors making a third vector. Two different vectors making a third vector. And it always comes in this parallelogram form where you have it right there. It's always like that. So the question is, what do I do for the math? Well, I have to add the components. I always just refer to it as the plane vector and the wind vector. And the plane vector is pretty simple here. Well, let's do the wind vector. It's a little bit easier. It's at 45 degrees. So it is 125 cosine 45. 88.4. We can go ahead and round here. It's not unit circle values. Well, that one is, but we're going to go ahead and round on the final answer anyways. And 125 sine of 45. It's going to get us the same one, but here's the tricky part here. What's the angle here? It's going at 300 miles per hour, or a force of 300, and that's the magnitude. But what's the angle? You have to put a 0 in there. So that's probably the hardest part of this problem. Make sure you put a 0 in there for that vector. And it's just 300 cosine 0, 300 sine 0. Add these components, and then figure out whatever you need to do with those parts, whether it's magnitude or direction. Alright, last problem I'm going to do are these formulas right here where you do the angles between them. Well, let's go ahead and sketch those. 1, 2, 3, 1, 2, 3, 4. There's 1. Negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, and it's out there. Looks an awful lot like a right triangle. Well, is it? Well, we take the cosine of theta. It's a formula. On the top is a dot product, and that is simply negative 3 times negative 7 plus 4 times 5 is negative 1. And now I put the two magnitudes on the bottom. This one, a squared plus b squared equals c squared, would be 25, root 25. I'm just going to leave it like that. And this would be 49 plus 25, root 74. Well, that's going to give me a decimal. Let's see what this gives me. Negative 1 divided by square root of 25 times 74. I'll put them both underneath there. And now I'll inverse cosine that answer, 91.3 degrees. And looking at that does match to what it should be. Alright, I hope this helps. Again, it's the hardest part on this problem is drawing the vectors, but they're all the same. They make a parallelogram. They look like that. And then once you have what you need, add the components. Can't add it in this form, add the components, and then you can find the direction with tangent inverse b over a. You can find magnitudes with a squared plus b squared square rooted. Alright, hope this helps.